All right, this is the last of the three integrals review videos, and we're going to do a couple examples of U substitution. So it's a very important technique that we'll use throughout the rest of the calculus sequence. So we'll go ahead and work out a couple examples. Everybody's going to be different how much practice they need to start recognizing patterns. So this is not a basic integral that we know. So we in Cal 1 we really only had U substitution as a strategy. One of the big strategies, at least. So we'll let U equal x to the 6 plus 9, and because the derivative of x to the 6 is 6x to the 5th, it's the x to the 5th part that we really want. So your differential du is equal to 6x to the 5th dx. Now there are a variety of different ways people do the U substitution. What I've noticed in the videos associated with homework problems and also in the textbook, it seems to be generally they solve for dx. And so if we solve for dx, we have du over 6x to the 5th is equal to dx. And the idea of any sort of substitution, U substitution, trig substitution, is to replace everything in terms of x with something in terms of u, or if you're doing trig substitution later on, in terms of theta. Okay, so you have x to the 5th still there, and then x to the 6 plus 9 is u, and then dx is du over 6x to the 5th. And notice that you have a factor of x to the 5th in the numerator and the denominator, so this is going to absorb. And so we're simply left with the 6 in the denominator will slide that out, so 1/6 integral of du over u, which is going to be 1/6 natural log absolute value of u plus c, and then go ahead and replace the u with what it was equal to, which was x to the 6 plus 9, and then plus the constant of integration. Now, technically you do not need the absolute value because x to the 6 plus 9 is guaranteed to be positive. The domain of a logarithm is going to be all positive numbers. It's a happy creature, doesn't like being fed anything negative or zero. Okay, it doesn't hurt it if you leave the absolute value parts either. Okay, number 19 here. So we're just following the same ordering from the derivatives and the integrals numbering. The trig review, I think the numbering got a little bit off because it was from another set of notes and videos. So I apologize. Those won't line up with this. They'll be correct from the handout. It's just they won't follow the order of these two. So anyways, it's not too big of a deal. You just follow the handout that's on your guys' blackboard. Okay, number 19. We're going to take the integral of dx over x times the natural log of x to the 5th power. And so we know that the derivative of natural log of x is 1 over x, and that's exactly what we have there. We have x in the denominator, so let's go ahead and do that. U is equal to the natural log of x. Du is equal to 1 over x dx. You can go ahead and solve for dx, and you have x du is equal to dx. Okay, so then we'll go ahead and do the substitutions. Okay, so the x is still there in the denominator, and then we have u to the 5th in the denominator, and the dx is x du. So there's the dx, x du, all over x, and then u to the 5th. Notice the x is absorbed, so we have everything in terms of u. So this is going to be the integral of u to the negative 5 du. Add 1 to the exponent, divide by the exponent, plus c. It's going to be negative 1 over u, which is the natural log of x, raised to the 4th power. Don't forget your constant of integration. Okay. All right, I think I got 3 more for you. All right, let's look at the integral of 8 sine to the 4th x cosine x dx. And when we have a combination like this, you want u to be the base that has an actual power here. So here we have sine to the 4th, so you want the u to be the sine of x, and then the differential du is going to be cosine x dx. Now, you can solve for dx. It's not a problem. I'm just going to save us a little bit of time here. cosine x dx is exactly du, so you can just go ahead and replace cosine x dx with du. And so we're going to have the integral of 8 u to the 4th du. Okay. You can still solve for dx, it's just a little extra work, not much. Okay. Add 1 to the exponent and divide by the exponent plus constant of integration. So we have 8/5. Replace the u with the sign of x. That's to the 5th power and then plus c. Okay. All right. I've misread. It looks like I have 3 more. I'm sorry. Okay. We're going to do a definite integral. And we're going to do U substitution, and we can do a change in variables with the definite integral, and we'll go ahead and see how that works. So here we're going to let u equal negative 7x. Differential du will be negative 7 dx. Okay. Now we're going to get a numerical answer for this definite integral. And so what we can do is we can convert everything in terms of u, including the limits of integration, and then we don't have to go back to x. So that's why we like this. So we're going to go ahead and solve for dx, and then we're going to convert the limits. Okay, we're going to convert those limits. All right, so you have u is equal to negative 7x there, and so that's going to tell us how the u limits are going to be. So the old lower limit was negative 1. So then your new lower limit is going to be 7 once we plug that in. So x is equal to negative 1. U is equal to negative 7x. So negative 7 times negative 1 is going to be positive 7. So that's your new lower limit. Your old upper limit was 0. And when we use our relation u is equal to negative 7x, that's going to give us also 0, so the upper limit ends up being the same there. Okay, and then we have 3 to the u. We solved for dx, that's du over negative 7. Okay, this is good to go, so we don't have to go back to x. We just use our new limits of integration, 7 to 0. Okay, so the integral of b to the u du is going to be, well, let's slide out the negative 1/7. It's going to be b to the u over the natural log of the base. And we're going to evaluate that from 7 to 0. We can go ahead and slide out the natural log of 3 in the denominator. So 3 to the 0 minus 3 to the 7th. Working that out, we get 2,186 over 3 natural log, over 7 natural log of 3. So 2186 over 7 natural log of 3. Again, this would be the area under the curve, bounded by the x-axis between negative 1 and 0, the curve being 3 to the negative 7x. So that's a decent amount of area there, because this particular exponential, because of the negative there, that is going to cause a reflection, and so it's going to be a very fast growing. So you want to have something like this, and so just to give you a rough idea, that's the area there that you're finding. Okay, so moving on, we're going to do another one with the U substitution and also converting the limits. So this time I'm going to go the integral from 0 to pi over 3 of the sine of 3x dx. Okay. We'll let u be 3x, du will be 3 dx. Solving for dx, that's du over 3 is dx. Convert your limits. Okay, old lower limit was 0. The relation is u is equal to 3 times x, so 3 times 0 is 0. So the new lower limit is 0. X is equal to pi over 3, so you have u is equal to 3 times pi over 3, which is simply pi. Okay, so that's your new upper and lower limits. Sine of u. Dx is du over 3. Slide the 1/3 out. The integral of sine is minus cosine, so that's where the minus comes from. negative 1/3 cosine u, and then you're using your new limits of integration. There's no need to go back to x. Okay, so negative 1/3 cosine of pi, which is negative 1, minus cosine of 0, which is 1. So this is going to be negative 1 minus 1, so that's going to be negative 2. So negative 1/3 times negative 2 is positive 2/3. Okay. All right. I got one more for you. I'll post some other links to more examples of this, or you can always shoot me an email if you want more video examples. Okay. So one more here. Another U substitution, and this thing just looks horrible, but it works out pretty nicely. So again, just kind of knowing your basics of derivatives really helps you out with the U substitution and integration. So we're going to look at the integral of negative tangent of x times the natural log of 3 cosine x dx, and this just looks horrible. And so if you know the derivative of the natural log of u, where u is a differentiable function of x, for instance, 3 cosine of x is a differentiable function of x. That is u prime over u. So I'm going to go ahead and look at that, and this is going to work out pretty nicely. So we're going to let u be the natural log of 3 cosine x dx, sorry, no dx yet, and we shouldn't be saying dx there. We haven't taken the differential yet. Okay, du, so we're going to go ahead and take the derivative of natural log of 3 cosine x, okay? So different u, but it's going to be u prime over u. So derivative of 3 cosine is 3 sine x, all over the u, which is the inside of the logarithm, which is 3 cosine x, and then differential dx. 3 is absorbed, and we have negative tangent of x dx, which appears exactly in the integral, so we can go ahead and just make a direct substitution. So the negative tangent x dx becomes du, and then the natural log of 3 cosine x becomes u. Thus we simply have the integral of u du, simple power rule, u squared over 2 plus c. Okay, so that's the natural log of 3 cosine x, quantity squared, over 2 and plus c. Okay, and so that's it for now. Again, I was bumbling along and bumbling away through about the trig review, so that's the last part on the review, and I just wanted to say that the numbering system is a little bit off on those, so it corresponds to the video and the handout correctly. It's just, it's not going to be, the next problem is going to be 24. Okay, we'll see you next time.